I was one of 5 designers that were responsible for developing the first Cirrus certified aircraft called the SR20. And this has been the world's best-selling 4-seat aircraft since it was first delivered. We were able to then, in 30 days from start to finish, show our executives something that we couldn't have done in 4 months here. And it was only done because we were creative enough to figure out how to build a full-scale prototype using additive manufacturing, which I, to this day, appreciate.
Solutionology is about being unyielding with perseverance to get to the solution.
To not give up and to constantly drive for better. So even when we deliver 100%, I want to deliver 110 next time.
And for me, the constraints of that project are the most important because that's what drives us to a solution. It's all about painting a picture and getting all the details in.
How do we develop a tool that helps share our journey, educate others, and bring more light to the realities of additive manufacturing? The Solutionology podcast. Well, here we are on episode number 18 of the Solutionology podcast. You know, each one, they get a little bit more unique, and we continue to explore the process, the story, and really the messages that we're trying to deliver. And this, we've got a dear friend as our guest, an inspiring designer and a renaissance man of sorts. That's how I think about Mike Van Staagen. And it's someone who is I look up to from design and creativity, and just a great perspective of life and how to maximize it. So I'm really excited to have Mike on. Brian, we've been working with Mike for solid 6 years, 5 or 6 years, and through that time, I've really had a chance to learn from you, Mike, and also have some fun. Mike is currently the Vice President of Advanced Development for Cirrus Aircraft. Mike's got a storied career with Cirrus and an extraordinary career in the aerospace and aviation industry, as well as industries that are complementary to that from an advanced development standpoint. So, Mike, it's a privilege and an honor to have you on our podcast today. Thank you for joining us.
Well, it's certainly a pleasure to be here, fellows, and I do cherish our relationship. I look forward to any project that I get to do that leads me on a path to working with you guys, yourselves personally, and your team. It's been a very, very positive experience. So I really appreciate you reaching out and asking me to be part of your podcast today. And I'm extremely excited to share what I would call a very hidden message. These types of messages don't get out in the world very often, and this forum that you guys have is a really nice way to communicate it. And so I really appreciate you guys reaching out to me for this today. Thanks.
Well, thanks for joining us. And this we won't cover today, but your life chart that you shared with me has been extremely meaningful. So your education is very impactful, and I'm sure it will be today for our audience. So, Mike, today you're with Cirrus. You're VP of Advanced Development. But, your career is absolutely fascinating. One of your major career milestones, besides the SR20 and SR22 development, is you were also the impetus to the Cirrus jet.
I joined a team of extremely talented people. And to this day, I'm humbled often by what extreme talent exists at Cirrus and in this industry as a whole. This industry really appeals to people that are creative and want to do hard things. While I can tell you it's usually extremely uncomfortable to talk about myself because all of my accomplishments here at Cirrus has been team efforts, and I've been lucky to be sometimes the author of things, and I get the credit for that. But it usually comes from a lot of people. So with that said, so I was one of 5 designers that were responsible for developing the first Cirrus certified aircraft called the SR20, which also turned into the 22 with a larger engine. And this has been the world's best-selling 4-seat aircraft since it was first delivered. It has been on top of the pile the whole time. And I like to think that I brought some pretty clever ideas to the aircraft that helped it get there. And I'll give you a couple of really great stories. And this was before additive manufacturing was even existed, at least at the consumer and small business level. My responsibility was the fuselage, which is the body of the aircraft. Because I was fairly aggressive, I took over sort of the aesthetic treatments of wingtips and other things that I could affect that would help contribute to the overall aesthetic of the design. There was something, as an architect, you dream of doing the skyscraper or the Guggenheim Museum. A person like that typically pines to do something where they're basically the author of it. I had all that, and I was really, really, really excited about trying to push Cirrus into the next airplane. The Vision Jet, what was really curious to me when I was trying to figure out how to make this airplane a reality was I was trying to leverage everything I had available to me in my toolbox. As I mentioned before, composite construction allowed you to make these beautiful flowing 3D shapes, very aerodynamic in general principle. What I was attempting to do was increase the amount of cubic feet on the inside of the airplane but also keep the airplane as small as I possibly could, because the smaller an airplane is, the faster it will go on a given power, more or less, as a rule of thumb. But if you were to sit at your local coffee shop and look outside and watch the vehicles go by, you see single people in minivans and big trucks. And so you think to yourself, what in the world is going on? Why isn't everybody on bicycles and scooters, for crying out loud, or single person cars? Because that's really how humans really travel most of the time. They don't do that. The reason they buy the minivans and the cars is because of the other parts of their lives where they need to haul something or bring grandkids along, or people and bags and groceries and things like that. So you buy the vehicle because of the overall utility that it's going to bring to you. So I wanted to increase the size of the cabin for the size of the airplane. I'm 6'4", and I really like to fit in things. And so it was probably good that I was trying to size the inside of the airplane. Again, I wanted to make the experience for the passengers the best it could be. So getting these big windows in the right spot, the right number of seats. And so anyway, I had a couple of really creative ideas on how to do the seating, and staggered that and made a center seat that could slide back and forth. So you could have a variety of options, just like the Chrysler stow and go seating concept, right? Seats when you need them and they disappear when you don't. Wanted to have those types of that type of logic in the aircraft design. So I'd come up with a handful of really strong, bold concepts. I was sort of hell-bent on making that happen, and eventually developed a full-scale fuselage of the Cirrus Vision jet all by myself. And it was really tricky because building, it was a very rough mock-up, I'll say, but it was made of foam and fiberglass, and the foam was from Home Depot or your Lowe's stores, and I fiberglassed it up myself, and then made the seats out of wood and fabric, and covered it with house paint. I mean, it was very, very low cost, but over about a 7-month period, I was able to design and build the fuselage of the aircraft that, guess what, became the ambassador for my ideas. Explaining them in model form, I did that for many years, and by the time I finally got the go-ahead to build this prototype by myself, it was all on the line. It had that the final mock-up had to show that. Through a series of models, about 7 or 8 of them, I came up with the final sort of shape of the Vision jet and how it was going to look, and everybody could get the concept. But of course, it was a small desktop model with only about an 18-inch wingspan, and the fuselage was size of a grapefruit. I needed to translate that to full scale because a lot of my ideas were on the inside of the airplane, and it was at human scale. And so I built the fuselage from the nose to the back of the back seat, basically the cabin volume plus the nose. And I had already gotten, the sign of approval from the desktop model. The model was all built, and I brought the 2 owners of the company in to see it, and they absolutely were shocked when they first saw it, because the proportions without the tail, if you think of a tadpole, right, you have kind of a big bulbous front and a long skinny tail. The tail was missing on my tadpole, so it made it look out of proportion. And he looked straight at me 5 seconds after opening the door and looking in. He's just like, "What happened?" I was like, "Nothing happened." He's like, "Why does it look so fat?" And airplanes need to look long and skinny and slender and sexy. And I was like, "What are you talking about? I'm offended by this." And I said, it's exactly this model, just in scale." He goes, "Well, it doesn't look right. There's something wrong here." And I won't labor you, but I've gone through this process before. So it started out with that house model that I explained earlier, and another project that I did where the drawings and the models and the full scale didn't work. And so I knew what to do. This was a Friday. So over the weekend, I built a skeleton version of the tail, a lot like those wood dinosaurs are made with lots of flat plates, right? So I made the tail and I got it stuck up there, painted it all white. And on Monday, we were bringing the board of directors through. And when they walked in on Monday morning and saw the tail, he looked at me and he winked and gave me the, "You killed it, guy. You nailed it." And so that was another experience of how incredibly important proportions are. I have another saying that I'd like to use, and it's, I guess I have a lot of dumb sayings, but this one is good. And I call it eighths of an inch, 1/8 eighths of an inch. It is amazing how people can perceive the difference of minute proportions. Another analogy I use is if you like to look at beautiful people in magazines, right? You can tell we all have eyes and noses and mouths and hair and ears, but there are people that people say those are beautiful people and others that aren't so beautiful. What makes the difference? Microns. The tiniest proportional differences between eye shape and eye placement, and nose and nostrils and lips and teeth and all of the pieces that make up a face. But you can see we have 7-8 billion people on the planet. We all look different. And these are extremely tiny, tiny proportions. So I use this thing called eighths of an inch to try to express how sensitive humans are to proportion. And we try not to forget that. One of the first big project you and I did together for Cirrus was a fuselage of an airplane. And that fuselage was to demonstrate this principle called eighths of an inch. We had a wood mock-up. We had sort of that dinosaur frame skeleton that we referred to before, but nobody could really see the airplane in it. So we set out together to build the fuselage, where I provided you guys the exterior shell, and you figured out how to build several hundred pieces in your printers and assemble this airframe and deliver it to us. And we were able to then, in 30 days from start to finish, show our executives something that we couldn't have done in 4 months here. Building it ourselves in our traditional way of composite tooling and construction, even our prototyping construction. We showed in 30 days what the proportions are of the new design, because the design had changed and people wanted to sign off on it. And it was only done because we were creative enough to figure out how to build a full-scale prototype using additive manufacturing, which I, to this day, appreciate. And as we talked about before, as these new aircraft are starting to materialize on our CAD drawing boards, if you will, we're going to be doing that again and again. So quite an accomplishment that we did as a team, I would say. But eighths of an inch, don't forget that.
There's a lot there, and to cap it off with that story, that was an incredibly intense project, and you had the vision there. You were experiencing, as part of the team, you were experiencing the challenges internally with the proportion challenges. And you knew what was possible with 3D printing, with additive manufacturing, and brought us the challenge. And that was a great big project that we got to work on together successfully. So thank you for having that vision and being able to help us see and push us to achieve that.
Yeah, it was really quite an accomplishment. I never really thought we could print a whole fuselage like that. So it just goes to show what creative people can do. Put your minds together, right?
I always love seeing your name pop up on my phone, because I think to myself, now what is Mike going to say? What if, could you guys? I always love those phone calls, because it pushes us to think about something new from a different perspective.